Alright, so here we're going to look at a review of exponential functions. So what we see right now is that they always take the form y is equal to a times b to the x. And what makes us our exponential function here is that our x is in the exponent. So we see that they're labeled here, but our our a is always our y-intercept. Or when we're writing out our exponential equations, it's our starting value, whatever we started with. And the b value helped us determine if we were growth or decay. So if b was larger than 1, we knew that we were growth. If our b value was in between 0 and 1, we have decay. Alright, so what we're going to do now is look at the steps to be able to write an exponential equation. So whenever they give us a growth or decay rate, they'll give it to us as a percent. So in order to work with that, we must first turn it into a decimal. So what we do is we take that percent and we divide it by 100. So once we have our decimal answer there, which represents our percent, we're going to have to do one of the two things. If we have growth, we're going to have to start off with 1, which represents our initial value, and we'll add that decimal on. So then that will be our growth factor. Now, so 1 plus the decimal will give us our growth factor, our b value. Right, and the same thing for decay, except what we have to do, we're still going to start off with that 1, which represents our initial value, and we have to subtract that decimal. And then the leftover amount will tell us what our decay factor is. So let's look at a couple of examples and try this. So it says a population of 40 roaches and increasing at a rate of 18% a week. And so for part A, it wants us to write an exponential model to number the amount of roaches in x weeks. So what we'll do is we'll say y is equal to, now we're thinking exponential equations here, so y is always equal to a times b to the x. So we need our starting value here, which is a 40. You see that in the problem. Okay, and now to find our growth factor, our b value, we need to do the following. We need to take our percent, so we have our 18%. Once we divide that by 100, we get a 0.18. And once I add 1 to that, it will give me my b value of 1.18. And that's what's having us grow here with our exponential growth. We have our starting value of 40, and then the 1.18 is our growth factor. So it's the 1, which represents our initial value, plus that additional 18%. So when it wants us to calculate the number of roaches in 10 weeks, let's use our equation to do that. So we have our starting value, we have our growth factor, and since x represents the amount of weeks here, our time, we'll put in a 10. Now when we use our calculator to help us accomplish this, we'll just type it in just like it looks. Make sure you push the up arrow to get your exponent. We get 209. So we'll call it 209 roaches. Alright, so there's one of growth. Let's take a look at one for decay. So a new truck is purchased for $40,000 and it will depreciate. There's our hint that we're looking at decay. 12% per year. And so it wants us to write an equation. So we have y is equal to our starting value. Here is our 40,000. Now we need to find our decay factor, our b value. And we do that, we take our 12%, divide it by 100, and we get our 0.12. So once I take 1, which represents my initial value, and I subtract that 0.12, we get that our decay factor is a 0.88. Right? And we have our x here and our exponent. So this would be the equation, and we'll be able to use that to calculate the value of the truck in 5 years. So we'll take our 40,000, we'll multiply it by our decay factor, which is 0.88, and then one in this for after 5 years. So whenever we enter this into our calculator, we will get a number here. So don't forget our dollar sign is our units. So we have 21,109 and 28 cents.